Alright, so we are looking at trigonometric identities, deriving the 20 identities using the 4 first fundamental trigonometric identities. So we are going to begin with number 4, cos A minus B is equal to cos A cos B plus sin A sin B. Then we are going to let A equal to B equal to theta. Then we are going to replace where there is A and B with theta. So cos theta minus theta is equal to cos theta plus sin theta sin theta. Okay, so from here we see that cos in the brackets we have theta minus theta, we're going to get a 0 there. So we get cos 0 is equal to cos times cos theta. We are going to have cos square theta plus same as sin square. We're going to have sin square this side, sin square theta. Cos 0 is equal to 1, and this we are going to have cos square theta plus sin square theta. So this happens to be identity number 1. Then we can also make sin square subject to the formula, where we will say sin square is equal to cos square theta minus 1. This will be our identity number 2. Then we can divide through from cos square plus sin square is equal to 1. So we're going to say cos square theta plus sin square theta is equal to 1. So we are going to divide through by cos square over cos square theta over cos square theta over cos square theta. Then from here we understand that cos square over cos square, we're going to get a 1 plus sin square over cos square theta, we're going to get tan square theta. This is equal to 1 over cos square theta, we're going to get sec square theta. And from here we can make 1 the subject. We're going to have 1 is equal to sec square theta minus 10 square theta, and this will be our identity number 4, and this one will be our identity number 3. Okay, so we see that 1 is equal to, here we can have a difference of 2 squares, so we're going to have sec theta minus tan theta, and this side we also have sec theta plus tan theta. So this is our identity number 5. Okay, so after doing this we see that tan, we can also say tan square theta is also equal to sec square theta minus 1. Right, so since tan this side is squared, we are going to square both sides, and so we are going to get actually this one will be our equation number 6. Then we are going to have tan theta is equal to plus or minus the square root of sec theta sec square theta minus 1. Then from there, we are going to say this is our equation number 7. Equation number 7, and we're going to say tan theta is equal to plus minus the root of, so this one is going to be 2 different of squares, sec square theta, not square but sec square, sec theta minus 1, like that, and sec theta plus 1, like this. And this gives us the 7 identities up to now. So now we can consider equation number 1, and then we are going to divide through by sine square. Okay, so we consider equation number 1, which is so I'll say consider equation number 1, then sine square cos square theta is cos square theta plus sine square theta is equal to 1. Then we are going to divide through by sine square. So over sine square over sine square theta, like that. Also here over sine square theta. And from there, we are going to find that cos square divided by sine square theta, we are going to get cot square theta plus 1, and this is equal to cosec 1 over sine square theta is equal to cosec theta, or cosec square theta. Okay, then from there, this will be our identity number 8. Identity number 8. And then we are going to have, we're going to make cot square theta subject. This will be equal to cosec square theta minus 1. This is our number 9, equation number 9. And also we are going to say we make a different of 2 squares from what we have here. We're going to have cot square theta is equal to, so the different of 2 squares will be cosec theta minus 1 and cosec theta plus 1, like that. Then we see that from equation number 9, and this one is equation number 10. Equation number 10. Then we see that from equation number 9, we can square both sides, and then we can have something like the one we had here. Okay, so we reconsider cot square theta to be equal to plus or minus cosec square minus 1. We square both sides, so this and that one cancels, so we're going to remain with cot theta is equal to plus minus, we are going to make the difference of 2 squares from this one, cosec minus 1 and cosec plus 1, like this. Right, so now after this, we are going to let this be equal to equation number 11. After it being equation number 11, we can also say 1 is equal to cosec square theta. 1 is also equal to cosec square theta minus cot square theta, and this can be equation number 12. Equation number 12. We can also say 1 is equal to cosec, since this can be different of two squares, cosec theta plus cot theta, and cosec theta minus cot theta. This can be your equation number 12a or 13. It's okay. So now we are going to consider equation number 3 from the first 4 fundamental equations. For now, we can end here for equation number 4. So we consider equation number 3, which is cos A plus B equals cos A cos B minus sin A sin B. So also here we are going to make the same assumption that A and B equals theta, and so we are going to replace everywhere with theta. So we're going to say cos theta plus theta, this is equal to cos theta cos theta again minus sin theta sin theta. From this we see that this becomes cos 2 theta is equal to cos square theta minus sin square theta. Cos square theta minus sin square theta, and this would be equation number 13. Okay, so this being equation number 13, we are also going to say, you remember from what we derived from equation number, identity number 4, that cos square is equal to 1 minus sin square. So we're going to say cos 2 theta is equal to 1 minus sin square theta minus sin square theta. So here I've just replaced this. Actually here you're supposed to say, recall that cos square theta is equal to 1 minus sin square theta. Okay, so here cos 2 theta is equal to 1 minus sin square theta minus sin theta. So here what we are going to have is cos 2 theta is equal to 1 minus negative sin theta minus sin theta. We're going to get 2 sin square theta. So we see that we are going to have equation number 14. Equation number 14. Since we have this, we can say we can make 2 sin square theta to be equal to 1 minus cos 2 theta, and then we can divide through by 2, and we are going to have sin square theta being equal to 1 minus cos 2 theta over 2. Right. So since this is also squared, we can have this as equation number 15. Since this is also squared, you can say you make sine square square both sides, then you have plus or minus, you square also this side, so we are going to get 1 minus cos 2 theta over 2, and then we have finally sine theta is equal to plus minus the root of 1 minus cos 2 theta over 2. So this represents the standard total angle, the standard total half angle of the trig identity, of the sine trig identity. So this is the half angle of the trig identity. Okay, so we are going to consider equation number so we are going to consider equation 13, and that is cos. Okay, let me do this. Okay, so we now consider equation number 13. This is the equation. Cos 2 theta is equal to cos square theta minus sine square theta. Then from here we can also say sine square theta is also equal to 1 minus cos square theta. So we are going to say cos square theta minus, so I'm just replacing sine square theta with 1 minus cos square theta. So I've started from this side, so that would be 1 minus cos square theta, and this would be equal to this one. Okay, cos 2 theta. Okay, then from here we see that we are going to say cos square theta minus, so this multiply what is inside, minus 1 plus cos square theta is equal to cos 2 theta. Then from there we see that this side we are going to have cos plus cos. We're going to have 2 cos square theta to be equal to actually minus 1. This one, this will be equal to cos 2 theta, right? Cos 2 theta. So we are going to take this one to the other side, and we are going to have 2 cos square theta is equal to cos 2 theta plus 1. Then we can divide through by 2, and by 2. That one goes. We have cos square theta to be equal to cos 2 theta plus 1 over 2. This is our equation number 16. Equation number 16. Equation number 16. Then we can also say we make cos square theta be equal to cos 2 theta plus 1 over 2. Then we can square both sides. Then this one goes. Cos theta is equal to plus or minus cos 2 theta plus 1 over 2. We see also that this is the standard half angle formula for cosine, right? So from here, this is our identity number 17. Identity number 17. From there now we can go to number 2, identity number 2, and see what we can get. Identity number 2. So identity number 2 is sine A minus B is equal to sine A cos B minus sine B cos A. Okay, so here we see that this is minus. Okay, so we're going to say sine theta minus theta is equal to sine theta cos theta minus sine theta cos theta. So you see that theta minus theta, you get 0. Sine theta, this will be equal to sine theta cos theta minus sine theta cos theta. So you see that this is the formula that we use to prove that sine 0 is actually sine 0 is actually going to be 0. Okay, sine 0 degrees is equal to 0, because if you press on your calculator, you're going to find that sine 0 will be equal to 0, and hence the whole of this thing becomes 0, because sine theta cos theta minus sine theta cos theta, you are getting a 0. Okay, so this is our identity number 18. Now we can also use we can also consider identity number 1. So this is the formula that we use to prove that sine 0 is actually equal to 0. So sine A plus B, this is the first identity, fundamental identity, is equal to sine A cos B plus sine B cos A. So from here, we are going to say sine theta plus theta. Remember, you replace where there's AB, put theta. So this will be equal to sine theta cos theta plus sine theta cos theta. Okay, then we are going to say, so this is going to be sine 2 theta being equal to, so this we are going to add these two, and we are going to get 2 sine theta cos theta, 2 sine theta cos theta, and this will be our identity number 19. Right, so we see that this side there is 2, and this side we can also divide through by 2 by 2. Then we are going to have sine 2 theta is equal to sine theta cos theta over 2, and this is also going to be our identity number 20. So this marks the end of deriving 20 identities.